Hi everybody, today we're going to talk about scientific notation and how to put numbers into and out of scientific notation. What is the purpose of scientific notation and why do we use it? Well, the main reason is because when we have to deal with huge numbers or very, very small numbers, it's very tedious to, work with those super long numbers. It's very easy to make mistakes when you have a bunch of zeros. So to kind of compress and condense those numbers down and make it easy for us to report those numbers, we use scientific notation. For example, if I was to ask you what is the speed of light, and you would tell me, well, it's 300 million meters per second. I mean, that's not that big of a number, but to give an example, if we would have to write the speed of light, the longhand version, every single time, that would be pretty cumbersome. So instead, we notate it or we express it as a scientific notation number. And this is how it's expressed: 3 times 10 to the 8th meters per second. I'm going to show you how to do that. It's actually quite easy. There's plenty of things that could be aided by using scientific notation. Like, for example, what if I asked you what the distance between stars was? It's a pretty long distance, and if you had to write that, if you're an astronomer and you had to write that in longhand version, that would be pretty tough and pretty easy to make mistakes. So scientific notation is a pretty useful tool that we use to write big or really big numbers or really small numbers. So before we go into how do we get scientific notation numbers, let's talk about some rules. Every number that's in scientific notation is based on the power of 10. The first number that you see is called the coefficient, and that number has to be between 1 and 10. So for example, I can't have a number like 0.35 times 10 to the 8th power, because 0.35 is less than 1. So that coefficient has to be between 1 and 10. The second number is called the base, and that is always in exponent form, and that's all obviously based on the power of 10. And the exponent is always a whole integer. You cannot have a fraction as a superscript there. It has to be a whole integer. So that's the generic formula for a number in scientific notation. Let's go ahead and try to put numbers into scientific notation. So for example, the speed of light is, as we said, 300 million meters per second. And here is what you see, right? You see this is how we would write the number normally. Truthfully, we know that we can go ahead and put this decimal here and put a 0 because that's meaning the same number, right? We're just saying that there's a decimal point after that last 0 right here. The reason that I do that is so that you know where to start from, right? So the decimal place is really at the end there, and what we would do is we would move that decimal place to make the number between 1 and 10. Remember, that rule says that the coefficient must be between 1 and 10. So we move the number 1, 2, 3, 4, 5, 6, 7, 8 spots. The ending number that we're going to have is 3. And that is a number between 1 and 10. And that number that you have chosen or that you have counted, that's what goes on the superscript of your base. So for example, it was 3 times 10 to the 8th because we moved the decimal 8 places. A good question that I used to always have, well, how do I know if the number is a negative number or a positive number? For example, how do I know if it's not 10 to the negative 8th? Well, the way that you can do that, or you can figure that out, is when you start with the first spot, right, which the decimal place is here. If you are moving the decimal place to the left and the number is getting smaller, then the exponent always gets bigger. It's always the opposite. And I put a quadrant here just so you can kind of visualize what I'm talking about. See, if you move the decimal place to the left, that number, 300 million, is essentially getting smaller. So if I move the decimal place from here to here, that number is not 300 million anymore. It's 300 million divided by 10. If you're moving the decimal place, and as you're moving the decimal place, that number gets smaller, then the exponent gets bigger. So that exponent is going to be a positive number. On the other hand, if you have a number like this, which this happens to be the mass of one hydrogen atom. Look how small that is. Look how tiny that number is. Imagine if I had to write that number all the time instead of using scientific notation. So now you can kind of appreciate the use of scientific notation and why it's so important. Here's the decimal place. And remember, to put it into scientific notation, we have to what? We have to actually have the number between 1 and 10. So we have to move that decimal place all these spots until we get to right here, 1.66, because 1.66 is a number between 1 and 10. If we did that and we counted, it would be 1, 2, 3, 4, 5, 6, 7, 8, all the way to 24. It's 24 spots. But how do I know if it's negative or positive? Well, as I moved the decimal place to the right, the number is getting bigger. So if the number is getting bigger, then the exponent gets smaller. And that's why it's negative 24. So the number correctly depicted in scientific notation would be 1.66 times 10 to the negative 24th. That's all you have to do to put numbers into scientific notation. Let's try and see if we can do some problems. So I want you to tell me if you think this number is in scientific notation. Let's go over the rules. Is the coefficient between 1 and 10? Yes, it is. Is the base a power of 10, and is this number a whole integer? Yes, it is. So that means that that is in scientific notation. What about this one? Well, remember, to be in scientific notation, you have to have a coefficient between 1 and 10, which this is, but you also have to have a base of 10. And here, there's no base of 10. Here, it just says 7.9. So this is not scientific notation. Let's go on to the next one. How about this one? 8.1 times 10 to the negative 4th. Well, that number coefficient is between 1 and 10, and this has a base of 10, and the number is a whole integer. So yes, it is scientific notation. What about this one? I hope you picked no, because this coefficient right here is not between 1 and 10. It's 12. So this is not a proper scientific notation format. How would we fix that? Well, we make pretend that the decimal spot, the decimal place is, or point is right here. So you would move the decimal point one spot to make it 1.2. 1.2 is between 1 and 10. So if you're moving to the left, that means that this number here is essentially getting smaller. So what happens to the coefficient? It gets bigger. So this number in correct scientific notation would be 1.2 times 10 to the 4th. I hope that makes sense to you. What about this one? Well, this one is also not in scientific notation for the same reason the one above isn't. 0.973 is not a number between 1 and 10. So you would have to move that decimal spot, that decimal point over here to 9.73. And of course, you would have to change the exponent. Try to do that on your own. Now, I want you to try to make these numbers into scientific notation. Remember, you got to have a coefficient between 1 and 10, and you got to have a base of 10 with a whole integer. Obviously, this guy does not have a base of 10. So how would you make this into scientific notation? Well, you would have to add the base of 10. So 8.45 times 10 to the 0 power. When you put anything to the 0 power, any number raised to the power 0 is always equal to 1. So in essence, what this is saying is 8.45 times 1, which is 8.45. Put this guy here into scientific notation. You obviously would need to move the decimal spot, which is not shown, but you assume it, right? Would be here, and you would move it 2 spots. And since you're moving it to the left, this number is essentially getting smaller. So that means that the exponent gets bigger by the same number of spots that you're moving the decimal spot, the decimal point. So it'd be 2.32 times 10 to the 5th. The next one would obviously be 8.43 times 10 to the negative 7th. These guys now are in correct scientific notation, and I would like you to move them out of scientific notation. So 4.863 times 10 to the negative 3, how would you move that into what we call a floating decimal? The negative tells you that the decimal point is going to go to the left. So by 3 spots. So the actual number ends up being 0.004863. For the next one, this guy is telling you that the actual number is 5 times bigger than this number. So you would have to move this decimal spot. Since it's a positive number, you got to move it to the right to make the number bigger. So the actual number is going to be 304,500. And then, of course, the last one, you're going to have to move it 9 spots to the left, making it that number right there. I hope this is easy, and if it's not, please practice some more because you need to be comfortable with moving numbers into and out of scientific notation. What if we wanted to add and subtract numbers that have scientific notation? This is something that is good to know, but we rarely use this technique by hand because everyone nowadays has a calculator, and the calculator pretty much does it for you. But of course, knowledge is power, and it's important to know how to do it just in case, let's say, your calculator breaks. When you're adding and subtracting numbers with scientific notation, you have to make each coefficient have the same exponent. You're going to have two numbers with two different exponents. It doesn't matter which one you put to look like the other one. They have to be the same. Then you combine the coefficients like normally, like if you're adding them. And then the exponents, when you're done with that answer, with combining the coefficients, those exponents stay the same. So for example, if I had 2.456 times 10 to the 5th plus 6.0034 times 10 to the 8th. These bases right here are different numbers, so you would have to basically make them the same. Either you have to put both of them to 8 or both of the superscripts to 5. So you can decide which one is easiest for you. But what I would do is I would move the decimal 3 places. So for example, 8 minus 5, the difference between these two numbers is 3 places. So I'll move the smaller superscript to make it look exactly like the bigger superscript. So that basically means if I'm going to move 2.456 and I want to make this exponent 8, I have to move the number 3 spots, or I have to move the decimal point 3 spots to the left, making it 0.002456 times 10 to the 8th. Now you see this superscript right here, and this one is exactly the same. Now we can actually add these numbers together, and all you would do is just add the numbers like normal, and you'll get 6.0059 times 10 to the 8th. This doesn't change anymore because you've already made the change before. I know this is a little confusing, but we rarely use this because when we're dealing with numbers in chemistry specifically in chemistry, the numbers are going to be way different as far as the exponents. You're going to have something that's minus 24, and you might be adding it to something that's an exponent to minus 3. You can't make that change in a timely fashion, so we're going to use our calculators. But it's always good to know how to do it by hand just in case. How would you manipulate scientific notation numbers when you're multiplying and dividing? This is a lot simpler than adding and subtracting. All you would do here is basically for multiplication, you're going to add the exponents, and for division, you're going to subtract the exponents. So here, 5.60 times 10 to the 12 times 7.102 times 10 to the 4th. Basically what you're doing is adding the exponents, 12 plus 4. So your ending number or your ending value is going to be some number to the 16th power. And there you go. You would get 39.8 times 10 to the 16th, but remember, we can't forget the rules of scientific notation, and that coefficient must be between 1 and 10. 39.8 isn't, so you would move it. 3.98 times 10 to the 17th. If you're dividing, it's the same thing, except now you subtract the exponents. So for example, the first one here would basically be 5 minus 2. So your ending superscript would be something to the 3rd power. It's 0.307 times 10 to the 3rd, but we got to move that decimal point to make it between the coefficient between 1 and 10, making it 3.07 times 10 to the 2nd power. And I'm sure you can do the last example by yourself. That's what you would get. And that actually is fine because the number is between 1 and 10, so it stays like that. Remember, a lot of this stuff is going to be done by your calculator. So for example, if I gave you something like 8.0 times 10 to the 4th times 5.0 times 10 to the 2nd, and you would put that into your calculator, it's going to give you a big number, right? It's going to give you 4 plus 1, 2, 3, 4, 5, 6, 7 zeros. But all you would need to do is tell your calculator, okay, put that into scientific notation for me, and it automatically tells you that it's 4.0 times 10 to the 7th. It actually just says 4 times 10 to the 7th, but you have to be smart enough after we talk about sig figs, significant figures, and how to report numbers with the correct number of significant figures, you're going to know that you have to actually report the number as 4.0 times 10 to the 7th. But my point being that the whole multiplying and moving the decimal spot and all this and that is really all done by your calculator. So don't really stress out. If anything, I might ask you one question on a simple example on how to move decimals or how to add and subtract or multiply and divide scientific numbers in scientific notation. All right, well, that's it for this video. I'll see you guys later.